3 approaches of connecting your factory systems. So before we start, let me share again a book that has significantly improved my understanding with large systems. And that is, if you read my blog articles, you already know it, Designing Data-Intensive Applications by Martin Kleppmann. It took me almost a year to read, but once I read it, I had a much deeper understanding into how large architectures work, because he's not only doing like, oh, what's better, Kafka, NATS, whatever. No, he's actually taking a look behind it. He's explaining, for example, how Kafka works or how a relational SQL database works with B-trees, etc. So you can actually understand what is going on in the background. And in this book, to now come to the topic, he describes 4 potential building blocks for designing data-intensive applications, how he calls it. So applications that consume and produce a lot of data. First are long-lived databases to store data. Second are short-lived databases, also known as caches, just to speed up expensive operations. I think we can ignore it for now because it's just speeding up expensive operations. Then we have stream processing blocks, so everything that you need to process real-time data. And then batch processing blocks, so you have now data for like a couple of years, and now you throw an algorithm on it, and that runs for a couple of hours, and then you get like a result of it. And every data-intensive application consists out of these blocks, and to connect them, there are 3 common architecture approaches, and we can put them and apply them exactly on factories as well. The first one is Dataflow Through Databases, Dataflow Through Service Calls, and then Dataflow through asynchronous message passing. Okay, this sounds a little bit scientific, but we go into it. So, option 1, Dataflow through databases. I think this is what most of you also know as historians. You have all your factory systems and you just write everything into it, everything to the database. It's very straightforward and it's all quite easy. So, advantage is simplicity. It's easy to implement and understand. However, it has a big disadvantage. There is no real-time processing possible. So if you put everything into the database first, there is always going to be some delay in it, a second or something. So if you want to have some real-time stuff, like you're taking pictures with cameras of products and then you want to do AI on it, whatever, or some other real-time controlling, you can't do it with that architecture. It's not possible. For this, you need to rip it out entirely. But luckily, there are 2 other approaches, just thinking top-down. The second option is Dataflow Through Service Calls. And this is what we commonly known as, in manufacturing as spaghetti diagrams. But it is a very good approach of doing things, and it works very well. It's just that in manufacturing, it kind of led to those, if you ever saw like a MES SAP chart, how everything works together, yeah, this is a spaghetti diagram. So you take a component and you do a one-to-one connection with them, and it is pro. You can do real-time, big advantage compared to the approach number 1, and it is very easy to get started with. However, there are also disadvantages. Spaghetti diagrams, easy to get started with, but as over time, over 10 or 20 years, when your factory systems are growing, there are more systems coming in. And every time you add a new component there, they will automatically, you need to do all the other connections to it. And then there's also option 3, which kind of combines everything, but also has a disadvantage, which is Dataflow through asynchronous message passing. Take a look here, and it introduces an additional component. It's called the message broker, where you have as a big advantage, you can send real-time data into it, and you can decouple all the applications to it. So they don't need to know each other. So if you have a PLC or some microservice, after 10 years or 5 years, you can just take it out. And if you just send the same data into the same format, all the other systems will keep understanding it. You can just, over time, you can let the system grow. So you can add just simply more components. So you can just tell a system integrator, hey, just send the data via MQTT, and they will do the connection, and then they can take data out of it and to visualize it. And in 5 to 10 years, even though you don't work with the system integrator anymore, you can still take out this data and do something else with it, which is very hard when doing like direct connections. But it also has disadvantages. There are 2. First, it's more complexity. Adding a new building block, it's always not so good. It's always bad because there's one component more that you need to maintain. And then also, second one, you're also creating a single point of failure. So what happens if this single block fails? Then all the other systems can't talk with each other anymore. But we are in manufacturing, because here systems run for 10 to 20 years. To be honest, we don't care so much about maybe some performance improvements, etc. It's all about maintainability. And over the long lifetime of such a system, it's important to be able to quickly add new components, maybe deprecate old ones, because in these spaghetti diagrams, this is what an Apple and a Netflix they can do, but they have very large software systems. And here in manufacturing, it's a system integrator or maybe some bachelor student that just comes in and does his bachelor thesis there, and this will stay in production for 6 years. So their maintainability is much better. But I also said that there is a disadvantage, which is the increased complexity to it. As always, there is no right or wrong, but in my opinion, the approach of using a message broker, asynchronous message passing, or also known as unified namespace, is the best approach of all the three. Thank you for watching, and for more relevant content, check out the description that you will find to this video. You will find all of our blog articles and other videos.